Hi everyone, welcome back to Gear Planet. Today we're taking an in-depth look at a modern hypercar, the kind of sculpted, mid-engine supercar you see here, and breaking down every major system, function, and engineering principle that makes it perform, handle, and feel the way it does. We'll walk through how the powertrain works, how the chassis and suspension keep you planted, what the aerodynamics and cooling systems do, the electrical and control architecture, and even how the interior and materials are engineered for both luxury and performance. If you love cars and engineering, buckle up, this one's detailed. At first glance, this car is a study in purposeful design. Very low, wide stance, sharp sculpted bodywork, large intakes and vents, dihedral doors that open upward, big wheels and low-profile tires, and a visible engine bay cover that hints at a powerful mid-mounted engine. Every visual element has an engineering reason. The low center of gravity reduces roll and improves stability, the wide track increases lateral grip, and the sculpted body channels air for downforce and cooling. Powertrain and engine architecture. This type of hypercar usually employs a mid-mounted internal combustion engine, commonly a naturally aspirated V10 or V12, or a twin-turbo V8 in modern variants, coupled to a high-performance dual-clutch transmission or a sequential gearbox. The engine's job is to convert chemical energy, fuel, into mechanical energy via combustion. Key subsystems include fuel delivery, high-pressure fuel pump, injectors, air intake, throttle bodies, airboxes, valve train, cams, valves, variable timing, lubrication, dry sump system for consistent oil pressure during high lateral loads, and exhaust-tuned headers and mufflers for flow and sound. Function breakdown. Combustion cylinders, pistons move to convert pressure into torque. High compression, precise ignition timing, and optimized intake, exhaust help maximize power. Turbochargers, if present, force more air into the cylinders to increase power density. Turbocharger lag is mitigated with careful turbine sizing, twin-scroll designs, or electric assist. Transmission. A fast-shifting dual-clutch gearbox lets the engine remain in its power band while delivering lightning-quick gear changes with minimal torque interruption. Drivetrain. Many hypercars are rear-wheel drive or all-wheel drive. A mechanical limited-slip differential or electronically controlled differential distributes torque between wheels for traction and cornering stability. Chassis, structure, and materials. High performance demands a chassis that is extremely stiff yet light. Manufacturers achieve this by using a carbon fiber monocoque or a hybrid aluminum-carbon structure. The stiffness resists torsional flex so the suspension can do its job predictably. The lightness improves acceleration, braking, and agility. Function breakdown. Monocoque, structural shell that supports loads from suspension, powertrain, and crash forces. Carbon fiber layups are oriented to carry anticipated stresses. Crash structures. Front and rear crush zones absorb energy in an impact while the central cell protects occupants. Mounting points. Engine and suspension attached to reinforced bulkheads or